Hello everyone, my name is Kalirin Modumil. Today I will be present my e-portfolio entitled Geophysical Mapping Investigation of Landslide Hazard, Seismic Reflection Imaging for Subsurface Characterization of Landslide Hazard in Kota Marudu, Sabah. This portfolio focuses on understanding the subsurface condition of landslide-prone area using geophysical method, specifically seismic reflection imaging. Landslides are one of the major natural hazards in Sabah and can cause significant damage to infrastructure, property, and human life. Therefore, identifying the factors that contribute to slope instability is important for disaster prevention and sustainable development. Before I continue with my presentation, let me introduce myself. My name is Kalirin Madumil and my matrix number is E24A320J. I'm currently a second year student pursuing a Bachelor of Applied Science in Geoscience with honor at University Malaysia Kelantan. My interest in geology came from my fascination with earth histories, fossils, minerals, and fieldwork activities that allow me to apply theoretical knowledge in real situations. Landslides are among the most common and destructive hazards worldwide. They occur when soil, rock, or debris move downslope due to gravity. Although surface observation can identify visible signs of slope instability, they often cannot reveal the interval structure beneath the ground. Therefore, this study proposed the use of high-resolution seismic reflection imaging, which is a non-invasive geophysical technique. This method works by measuring the travel time of reflected seismic wave to identify the subsurface layers, geological structure, and potential failure zone. The study area is Kota Marudu in northern Sabah. This area experiences frequent landslide because of intense tropical rainfall, steep terrain, and highly weathered geological features such as Crocker Formation. Unfortunately, detailed subsurface information in this area is still limited because conventional methods like drilling are expensive and difficult to conduct in mountainous region. As a result, there is a need of alternative method can be provide detailed subsurface information efficiently and with minimal environmental disturbance. My e-portfolio has three main objectives. The first objective is to evaluate the effectiveness of seismic reflection method in imaging subsurface geological structure. My second objective is to assess the effectiveness of GIS and remote sensing technique in identifying landslide susceptibility zone. And third objective is to identify and characterize the potential failure plan that may trigger landslide. Regarding the scope of study, this research focused on selected high risks in Kota Marudu, Sabah. The investigation will concentrate on imaging soil layers, determining bedrock depth, and locating potential slip surface. The significance of this study lies in its contribution in landslide hazard assessment. The finding can assist engineers, planners, and government agencies in making informed decisions regarding infrastructure development, slope management, and disaster mitigation. Since the method is non-invasive, it also minimizes environmental impact compared to drilling. Previous studies have shown that landslides are a serious issue in Sabah. According to Abdul Rasam and other researchers, landslides can occur in several forms, including soil movement, debris flow, and slope collapses. Research conducted in areas such as Kundasang and Ranau revealed that landslide occurrences are strongly to geological condition, tectonic activity, and geomorphological process. Geological formations such as Crocker Formation and Trismati Formation consist of weathered sandstone, shale, mudstone, and phyllite, which are highly susceptible to failure. This study demonstrates the importance of understanding geological conditions when assessing landslide hazard. Various factors influence landslide occurrence. Among these most important factors are slope angle, lithology, rainfall intensity, slope aspect, and human activity. Steep slopes generally have lower stability because gravity exerts a greater force on slope material. Heavy rainfall is often considered the primary triggering factor because it increases soil moisture and pore water pressure, reducing the strength of the slope material. Human activities such as road construction, deforestation, urban development, and land clearing can further destabilize slope. Although these factors vary between locations, most researchers agree that the interaction between geological conditions and rainfall play a major role in landslide occurrence. GIS and remote sensing technology are widely used in landslide studies because they provide valuable spatial information. GIS allow researchers to collect, store, analyze, and visualize geographical data. Meanwhile, remote sensing enables the collection information about the Earth's surface without direct physical contact. Previous studies have used factors such as rainfall, slope gradient, lithology, and land use vegetation cover, road, river, and fault line to produce landslide susceptibility map. The result of this study showed that GIS and remote sensing are highly effective tools for predicting landslide prone and supporting disaster management and land use planning. Early identification of landslide hazard is important for disaster prevention. Recent studies have demonstrated that combining soil thickness mapping with rainfall threshold analysis can improve landslide prediction. Researchers categorize soil thickness into several classes and analyze historically landslide record to determine critical rainfall threshold. This approach allows researchers to identify hidden landslide-prone areas before obvious signs appear on the surface. As a result, early warning systems can be developed to reduce risk to community and infrastructure. The equipment required for this study includes sledgehammer with impact plate, geophone, seismograph, seismic cable, measuring tape, GPS, seismograph software, and ArcGIS software. The seismic reflection method is based on the propagation of seismic wave through the earth. When seismic wave encounter boundaries between material with different acoustic properties, part of the energy is reflected back to the surface. The reflected signals are recorded by geophone and processed to create image of subsurface structure. The method is highly useful because it provides continuous subsurface information without needing drilling. Proper sampling is essential for obtaining high-quality seismic data. There are three important types of seismic sampling in seismic survey. The first is time sampling, which involves recording seismic signal at very short interval. The second is spatial sampling, where geophones are placed regular distance along the survey line. The third is source sampling, which refers to the number and distribution of seismic shocks. Data acquisition begin with surface planning, followed by source activation using sledgehammer and impact plate. The generated wave travels through the subsurface and reflect from geological boundary. The reflected signal by geophone are stored as seismic traces for further analysis. The survey consists of three major stages, and the first stage is data acquisition, where seismic energy is generated and recorded in the field. Locality of the acquired data is crucial because it affects all subsequent analysis. The second stage is data processing. Raw seismic data is often contain unwanted noises and distortion. Therefore, several processes techniques are applied, including denoising, deconvolution, stacking, and migration. This process improves data quality and produce clearer subsurface images. The final stage is interpretation. At this stage, we analyze the process seismic section to identify the rock layer, geological structure, seismic phases, groundwater zone, and potential landslide failure surface. This flowchart illustrates the complete sequence of research activities. The process starts with problem identification, literature review, and then it proceeds to survey planning, field data acquisition, data processing, interpretation, and hazard assessment. The final output includes subsurface geological model, identification of landslide-prone zone, and recommendation for future development and disaster management. This flowchart illustrates the complete sequence of research activities. The process starts with problem identification, literature review, and then it proceeds to survey planning, field data acquisition, data processing, interpretation, and hazard assessment. The final output includes subsurface geological model, identification of landslide-prone zone, and recommendation for future development and disaster management. This slide presents the project timeline and milestone. The project is divided into several phases, including proposal preparation, literature review, field data acquisition, data processing, interpretation, report writing, and then presentation. Each milestone represents important achievement that ensure the project progress according to schedule and completed within the allocated time frame. The research budget covers all expenses required to conduct the study successfully. These expenses include transportation to the study area, equipment usage, software requirement, field logistics, and other operational costs. A well-planned budget is important because it ensures that all research activity can be completed efficiently while maintaining data quality and project objective. This study is supported by various scientific journals and academic publications related to landslide, GIS application, remote sensing, and seismic reflection method. These references provide the theoretical background and methodological framework for the research. They also support the selection of appropriate technique for landslide hazard assessment. In conclusion, this research aimed to investigate landslide hazard in Kota Marudu, Sabah using seismic reflection imaging and GIS analysis. The study is expected to improve our understanding of the surface condition and contribute to better landslide risk management. Thank you very much for your attention and time, and I welcome any suggestion regarding my e-portfolio. Thank you.